Thank you. Thanks very much, man. So hello, everybody. By the way, how many of you guys read Virtual Geek? Just out of curiosity. Take a look at the blog post I just put up there. I guarantee there will be lots of tomatoes flying over that one. But it's great. Thank you for reading. If you don't read it, hi, I'm Virtual Geek. That's me. You can follow me on Twitter at SAKACC. I'm a pretty easy dude to find on the interwebs. And for any of you, that's an open invite. Like, these VMUGs are a really good opportunity for us to talk to each other. The most powerful thing actually is not to listen to the vendors, but actually talk to your peers and colleagues. There tend to be a lot of adverts, throughout the whole thing because, hey, VMUGs need funding to operate. But the thing that actually makes a VMUG work is actually the user group element of it, right? So I've always been a huge supporter. This presentation is going to be a little bit funky because basically when I started my blog, I started about 5 years ago. Somebody who's now at VMware, Chuck Hall, has kind of dragged me kicking and screaming. Like, I was like, dude, no one is going to want to read what I have to say. Like, it's kind of obnoxious, and it probably is actually a little obnoxious. But the thing that is interesting about it is the subtext is an insider's guide to the VMware revolution. I bleed VMware when cut on one arm, and I bleed EMC when cut on the other. I'm very passionate about what we're doing. And I think that VMware was changing the world 5 years ago. I think it's still changing the world. However, what I thought was going to happen in the industry at large is not actually what's happening. So we're going to zoom out of VMUG mode and kind of go a little broader aperture today, because I think it's important for all of us as IT practitioners to actually kind of have a broader view. Our businesses are looking at us not only to be awesome day in and day out, but kind of take them into the future. So I want to spin a little bit broader picture than you might expect today. So without further ado, thank you all for giving me even a little bit of time today. How many of you are EMC customers? Just show of hands. So thank you so much for being EMC customers in any way, shape, or form. Thank you for being VMware customers. Thank you for being the customers of our competitors, right? The world depends on you. The customers are at the front and the center. So thank you for what you do every day and supporting us. So, fundamental changes around the world. And I'm really lucky. I feel very blessed to have a job where I travel around the globe and I get to talk to customers of every size and shape. I've visited 10 customers so far while I've been here in Australia for the last 3 days, from the smallest to the small, biggest to the big. But I get to see customers all around the world, and it's amazing actually how consistent the dialogue is. Everyone thinks that they're totally different, that cultures and languages are wildly alien. From a technology standpoint, what's going on is pretty global, and what happens in one place quickly happens in another. If you had asked me when I started my blog, what will the world be like 5 years from now, I would have described a picture like this. Applications will all run as virtual machines. 100% virtualization, kernel mode virtualization is the goal. And it's going to be on vSphere universally because it is the best, and it is the best, and still is the best. And it's all going to sit on hybrid clouds. And we're going to build things. VCD wasn't even a twinkle in anyone's eyes, not to mention Dynamic Ops, aka VCAC, aka now the vRealize suite, right? But we kind of knew that people would be building and consuming IT as a service, and it's going to be built on infrastructure with giblets in it. I was wrong. So that's not what's happening. That's still the most of the world, but we're seeing a dramatic increase, like a divergence of the number of applications and types and architecture of applications that customers are constructing. We're starting to see divergence where people are embracing kernel mode virtualization in all of its forms for most stuff in the enterprise, but Linux containers and cluster managers, Mesosphere, Kubernetes, and stuff like that for some stuff, and Docker and Rocket containers, for other stuff. And we're seeing people go, OpenStack, should I use OpenStack? Should I not? Where do I use it? How? Do I use VMware integrated OpenStack or do I put it on top of KVM? Again, the majority still like VMware can be the one cloud for any app and any device, but it's interesting, it's broadening out rather than narrowing. And then how people are building it is turning out to be wildly different. No hyperscale cloud player uses hyper-converged architectures inside their public clouds. What they do is they use industry standard servers and distributed software components to build their public clouds at very large scale. We see hybrid clouds being built one way, and telcos are doing something called network function virtualization in yet a third way. So architectures aren't narrowing down. And then fundamentally, we see divergence of cold storage, all flash, all sorts of stuff happening. We're seeing a broader adoption of industry standard servers with software, but then on the flip side, we're starting to see a new wave of custom hardware being developed. So an interesting observation that I found about humans everywhere in the world is we want many things to ultimately become one. It's a desire that's deep in our hearts and our minds to have the complexity. Our brains all feel like they're leaking out of our ears, and somehow that eventually it'll get all easier, right? By the way, if you're a developer, this picture is even crazier. It went from like everyone will use Java to, yeah, there's a bazillion development frameworks, and if you want to write to something, you need to basically be a polyglot for persistence, which is a fancy way of saying you don't talk to a database like a SQL database. You talk to all sorts of different data fabrics. Like, it's crazy, right? The reason we all want simplicity is our hearts desire it. Deny it, reject it, embrace the chaos. It's the reality. That's kind of the message. So I hate to like not give you like a nice tidy, answer of, yeah, the answer is all flash arrays. That'll solve the world's, problems. Or, if you virtualize everything, you're going to be all good. One SDDC to rule them all, right? Not going to happen, in my opinion. Now, it may be that we can use this place where the chaos of variation of apps and infrastructures kind of narrow down to go, maybe there's a place where we can do some stuff to make the world simpler by automating at a very high degree, kind of in this intersection. Now, how many of you are developers? Or went to computer science, studied computer science in your schooling? Does anyone use if, this, then, that? You are a developer if you do, right? In some way, shape, or form. There's a very important thing. Now, how many of you are here responsible for some sort of infrastructure? Probably almost everybody. What is the role of infrastructure? To exist? To provide the vendor ecosystem reason for salespeople to go on to club? There's only one reason: to support the applications. Applications drive infrastructure, not vice versa. Something that infrastructure practitioners should never lose sight of. Why is that important? Application fabrics are changing. The way people are building apps are changing. The first thing to understand is the relationship between compute and data, persistence. For the longest time, and this is still true for the majority of applications, the distance between the compute and the data is measured in single-digit milliseconds. And thus was born the whole world of SANs and NAS and billions of dollars worth of industry and many, many moons of things. Now, vVols, blah, 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 blah. But the distance between them is measured in milliseconds. Everyone here in this room thinks about those applications as the world of applications that we support. I got a news flash for you. This is the smallest and shrinking set of applications. The fastest growing set of applications have the compute separated from the persistence in times or distances that are measured in hundreds of microseconds. So what the F is that, Chad? Has anyone posted a twit pic today? Picture on Twitter? Yes? If you did, where did it land? I don't know. I don't care. It landed on Amazon S3, which is an object store, which is slow when you're sitting right next to it. But do you think that the Twitter Cassandra databases, which was the thing that was the text part of your tweet, was sitting in the same data center where the S3 storage was? Was it on the same continent? Who knows, right? When I came in and went through the customs office and they scanned my passport, believe it or not, the Australian authorities at that moment actually process both my image, the text that's on my passport, and a whole slew of stuff from social media. And it goes and gets analyzed through a Hadoop cluster to actually determine, is Chad a bad guy or a good guy? And based on my Twitter stream, I'm amazed they let me into the country. Right? The point being that these use cases, the distance between compute and data is actually much bigger than what we're used to. We have a customer, a single customer, that buys an exabyte of storage from us every quarter. This isn't normal, but for perspective, that's 500 cabinets, 200,000 spindles worth of storage every single quarter. This is not the NSA, by the way. This is a commercial entity that I guarantee everybody here in the room has touched once or twice or 10 times today. I can't name who it is because these sorts of customers don't let us disclose their data centers or what they're using it for because they're a hyperscale cloud provider, right? That's another one of these examples like this. When you post a picture to Facebook, it lands on one that they grew themselves called Haystack, which is one of these. That volume of data is where the data is growing the fastest. Okay? Now, what's also happening here is that we're seeing compute get closer to data. Here, hundreds of microseconds. Every transactional system that you can't re-architect the app is moving towards NAND in some way, shape, or form. All-flash arrays, that sort of stuff. This is an area of very, very high growth. You see some workloads moving where the compute and the data are co-resident on the server. These are things like vSAN, like Scale.io. These are things like those telco clouds that I was describing earlier. And then you see some workloads where the compute and the data are separated not by microseconds, but by nanoseconds. In other words, the world of in-memory databases. This world of in-memory databases is how phone calls now occur. When you do stock trades, this is how it occurs. When your insurance company says, do I give you your policy, yes or no? This is how it occurs. It occurs in real-time machine learning algorithms that are all happening in memory. No one in their right mind that wants to build a very high-performance system puts it on Oracle anymore. Just, because that is slow. Like not a little slow, like 100,000 times too slow. Weird, esoteric, I know, but trust me, this is happening all around us. Now, the other thing that's happening in application land is changing ways to run workloads. Kernel mode virtualization, aka vSphere, yay! Right? On the right. In the middle, containerization. And by the way, those are not mutually exclusive. In the future, VMware has been very clear about saying we will make ESX and ESX variations that are the ideal place to run containerization. But today, most of the time, this runs on CoreOS. In other words, a bare-bone little Linux kernel, and use containers to deploy things. Why? How long does it take to deploy a virtual machine on vSphere 5.5? A couple minutes, right? And what do you get at the end? You get an OS that's running. If you're a developer, you then need to install the application stack on top of it. Maybe install some sort of database. You got to patch it. You got to maintain it. You can deploy a container in roughly 200 microseconds. Right? Rough and tough. If you're a developer and you want to go, I want to create 100,000 of those, that's handy dandy, right? And you don't patch and maintain them the same way. But if one of them goes a little wonky, it could affect them all. And then the strangest thing to me of all, as a passionate VMware believer, a insider on the vSphere revolution, is a resurgence of bare metal. Right? I never would have predicted that, right? What we're seeing is that for some workloads, not normal in the enterprise today, so don't, get all weirded out by what I'm saying, but trust me, it'll happen over time. There's an abstraction layer that exists separate from the hardware. So while you can run Hadoop on top of vSphere, and it's great, and I'm going to tell you why, in some cases with big Hadoop clusters, they actually are using the Hadoop layer as the abstraction and building tenancy inside the Hadoop layer. Right? Just interesting stuff going on. So which one of these is the winner? I don't know. You pick your tool. Right? The answer for most customers, by the way, is the one on the right. Just to be very clear. Right? The other thing that's going on that's interesting is the divergence of the world into what Gartner calls bimodal IT. I hate buzzwords. They make me barf in my own mouth. But it's sometimes accurate. There's applications that are pets. You name them, you care for them, you love them. When they get sick, you send them to the vet. And there's some apps that are like cattle or chickens. You never name them. When they get sick, you shoot them and eat them, right? In the world of chickens, things like VMHA are actually not a value add. No one deploys a cluster for these world of application chickens, because the idea of clustering it is building in resilience inside the data layer. No, you build resilience in the application layer. It's a weird new world, but trust me, I have a time machine. This will become increasingly important for all of us. When I say I have a time machine, I don't actually have a time machine, but it comes from talking to lots and lots of customers, right? You get to see little trends that boop, and then they go, and you see them everywhere. Now, those diagrams are cute, but this is the engineer's version. A pet has a web tier. It has a monolithic, giant, fat, bloated application tier. Sometimes these are enterprise applications that you buy off the shelf. You deploy them, and it takes you years and big waterfall projects and lots of planning meetings and stuff like that. And then that talks to a relational database tier. Could be Postgres, could be MySQL, could be Oracle, could be SQL Server, whatever, but it talks to something that is the single version of the truth. And then that runs on infrastructure, which is resilient. Infrastructure doesn't necessarily mean hardware. It could be vSAN on commodity hardware with VMHA, software protection, but it depends on resilience of infrastructure underneath that app layer. Does that make sense? That is the world of a pet app, right? In the world of a chicken app, they look like this. There's still a web tier, but there's this crazy loose coupling of what are called microservices, tiny little things. Some of them may not actually exist on premise. You might be accessing a microservice, which is like a Twitter API feed, like that customs example that I gave, right? They're just grabbing the data from that microservice. You have many of these. In some cases, you have thousands of them, right? And then this is built into what's called an application fabric. The weird thing is people are like, how the hell do these web services never go down? They must patch them or update them, right? And the answer is sometimes they do go down, by the way. But for the most part, their availability is actually like a tank. And it's because they never patch the whole thing. They update this little microservice or that little microservice, and the whole thing is evolving kind of chaotically all at once. These don't talk to a relational database. They talk to, again, this polyglot, which is multilingual, persistence layer, key value stores, distributed not only SQL and SQL databases. These are things like Cassandra, MongoDB, Hawk, HBase, that sort of stuff. Things like Gemfire, Memcached are example of these in key value stores. And then MapReduce is the thing which is used for big unstructured batch stuff. This stuff is all part of the Apache Hadoop project. This data fabric then ultimately sits on something that has no dependency on infrastructure resilience. That doesn't mean that there's not value in the infrastructure, but the things that are valuable are elasticity, manageability at scale. It's very different than IT, where it's like build it like a tank. Does that make sense? How many of you have anything inside your environment that looks even remotely today like the thing on the right? Does anyone? How much of your estate was like that 2 years ago? 0. How much of it do you think will be like that 2 years from now? Half. That guy also has a time machine. Talk to him and ask why. I have no idea what you're doing and why, but trust me, find him and talk to him, right? Now, the interesting thing about this is that this is the world of kernel mode virtualization. Kernel mode virtualization exists in this other world as well, but it's dominated by containerization, and this is where you see some of that physical stuff showing up, okay? Now, notice I just drew a line between the two. The thing on the left, I need to look at it from your side. The thing on the left is everybody else in the room other than that small percentage of that guy's estate 2 years ago. In other words, it is everything else out there. It is the entire world of the IT ecosystem. It's billions of dollars worth of vendors going after your business so we can help you grow your business, right? And the more we can save money there, the better. The world on the right is the majority of how new applications are being created, right? And that person out there is a reflection of that. Now, what's interesting is people have started to realize you cannot run pets on infrastructure built for chickens. If you try and take a workload that was built around this idea of resilience, this is why like the debates of OpenStack versus vSphere to me are really stupid, right? In OpenStack, the latest version of it, Juno, you still can't really create a clustered Nova instance. Like imagine, people complain about your, historically like the Microsoft clustering position around vSphere, right? Have any of you struggled through the like restrictions? By the way, in vSphere 6, it got a lot better even, so check it out, awesome stuff. What if I told you, nah, no clustering? How would you feel about that? Well, if you'd say, well, I can't deploy that, that means you live in a world of pets. But if you're like, why the hell would I ever want to deploy an operating system cluster? You live in the world of chickens. Does it make sense, kind of? Now, the thing that's interesting is you can run chickens on infrastructure built for pets. The question that every customer that's further down this journey is asking themselves is, should I? And some are determining the answer is yes, hence VMware integrated OpenStack, hence containers on top of vSphere, right? Some are saying, no, I'm going to build one infrastructure for my pets and another one for my chickens. You with me? Okay. An interesting piece of this is in the world of chickens, open source is king. If I say the word open source, what do you all say? Just yell it out. Whatever comes to your mind first. It's amazing. No matter where I go, everyone says free. Open source is not about free. Open source is about frictionless, easy IT, innovation, speed, and easy access, community. What's interesting is that open source software costs the same as closed source software. But in this world of chicken applications, things have to move super fast. This is forcing companies like us to change. We have to contribute to open source. There's this amazing site for EMC customers and non-EMC customers to check out called EMC Code. It's our GitHub repos for all of our open source projects. This is a weird new world. Trust me, dig in, it's fun. We're all passionate technologists. One of the things that is true of a passionate technologist is you can't be stopped from learning. The moment you start to get freaked out, it's a hint that you should learn something new. If some of the words I'm using are like, what the hell, GitHub repo, what? I didn't know what that was a year ago. So you learn, and that's a fun exercise, right? Next, data fabrics. What the hell is a data fabric? Developers never write to storage of any kind. Applications don't talk to storage. Applications talk to some sort of data fabric. A data fabric can be as simple as a relational database. In fact, that was the first one, right? And simple transactional databases begot ETL, extract, transform, and load, data warehouse, right? Things were good. Oracle was born, right? $1 billion Larry Ellison, the James Bond villain of IT, right? He has a boat, an island, like, come on. Have you seen his boat? Literally, at one Oracle Open World, I was there, and he phoned in from his boat for the keynote. Like, wow. That's a lifestyle. In any case, this is clearly still the dominant model of data fabrics, right? However, people realized that single version of truth, which is the guiding principle of that, meant it didn't scale. And so then people, Oracle, would never have invented this, but Yahoo and Google would. And they invented Hadoop. First, MapReduce, which is good for big batch jobs, and then they started to build this whole NoSQL, or not only SQL, on top of that HDFS layer. And things were good, but you had a whole bunch of little data ponds. And what's going on now is a ton of contribution and research into projects like Spark and Tachyon, which are in-memory databases which keep all the data flowing around between these different things. Let me give you an example, and I don't want to go into this in great length. This is an example of one of the world's biggest telcos. So they came to us and said, we have a 2 petabyte Hadoop cluster that we're struggling on how to continue to scale it. So what we did is it was all servers on just DAS, like low-cost servers and DAS. We put it on vSphere using the big data extensions, aka Project Serengeti, something really, really cool, freely available to any customer using vSphere 5 and later. And then we put it on Isilon. Isilon is, does anyone here use an Xbox? If you watch an Xbox movie, it's streaming off a giant Isilon cluster. Anyone here use Spotify? If you use Spotify, you are an Isilon customer in a sense, right? So Isilon backs many of these big pool of large-scale NAS or HDFS use cases. The net in the end was things got twice as fast, really important. It got, more important than that, cheaper. It's very counterintuitive. This was the cost of the servers. This is the cost of the servers after. This is the cost of the Isilon. This is everything else. And they went from 18 racks down to 8. Now, you may look at this and go, this is not me. I can fit my data center in a rack, right? Big data doesn't have to be big to be valuable. So many customers are actually finding that these techniques work at much, much smaller scales. The thing that I think is kind of cool is this is the before and after picture. So we basically took it off of the commodity servers with DAS, put it onto a dense UCS cluster, the Isilon cluster. So twice as fast, twice as dense, and twice as cost effective. Interesting. Now the other thing that's going on is persistence models themselves are changing. Why do I use the word persistence as opposed to storage? Watch this. I'm going to play another interactive cloud game with you. When I say storage, what pops in your head? There's some picture in your mind. Describe the picture. So I heard disks, right? That's what I heard. So something physical, some disks. If EMC customers, raise your hand. What color is the thing that's in your mind? Probably gray-black, right? Has a cool blue Cylon-like LED on it, right? NetApp customers in the room. What color pops in your head? Okay, what about Pure customers? Some orange thingamabob, right? You visualize something physical. Okay, so this is where our brains, our human brains kind of trip us up sometimes, right? Has anyone here deployed like a ZFS-based open source NAS thing at home? When you think about that, do you think of something physical or do you think of something software-y and then you put it on the servers? If I describe vSAN, do you think of a physical box? No, you don't. Are those all different variations of the same thing? Yeah, kinda, right? All of them are in essence software that is either decoupled from hardware or bundled with hardware. Persistence layers are really about software, not hardware. But our brains are wired that we think hardware. So that's why I'm using the word persistence as opposed to storage. Now, this is fascinating to me. So I spend a lot of time on airplanes, which is a little lonely. But I meet friends. It's nice, like all of you. And you can be my friends. Let's hang out afterwards, go for cocktails, whatever. It also means there's a good time to think and write. And I wrote a blog post around the 4 phylum of storage architectures. A phylum is the Latin word for like a branch in the tree of life. When you were in school, you remember how you're like, okay, there's like humans, fungus, and bacteria, right? Where humans and fungus are really close, right? Those branches of the tree of life are rooted in fundamental common origin, right? Everybody in the storage industry trips over themselves to say, my thing is totally new and different. There's nothing like it on the planet. It's a lie. There are only 4 branches in the trees of storage life. The first one looks like this. 2 brains connected to persistence. And I/O comes in, copied, persisted. What's an example of one of these? Who, what? A VNX is one of these. Give me another example. Just think of whose booths are out there. Who? VSP is not a one of these. Good guess, though. A NetApp FAS filer is a one of these. What about one of these new cool startups? Surely they wouldn't have one of these. Like what? Tin Tree, pure. Yeah. What about a software-only version of one of these? Any ZFS variation that you can think of is one of these. So notice, first observation, doesn't correlate with like traditional player, new player, doesn't correlate with software or hardware. This is a system architecture, okay? And by the way, there's no value judgment in my discussion here, right? And I'm not saying that they're all the same. They're all wildly variant, but they have this architectural thing in common. Sometimes with these, you can put something in front of it, like the thing doesn't have to be hardware, it can be code, that allows you to have multiple of them, and it moves and manages them as one. But if you think about the path of an I/O, whether it's block or NAS or whatever, it follows that boom, boom, boom. On a VNX, it takes 20,000 lines of uncompiled code to go boom, 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 down. Does that sound like a lot? It's actually not a lot. It's very thin. It's a lot thinner than like, many of your iOS apps, right? So it's a very code-efficient way to commit and persist in I/O. The next architecture are what I call tightly coupled scale-out clusters. They're tightly coupled because they share the same memory space. Every node, literally, if you could look inside the code, not physically how it looks, but inside the code, every one of the brains, software or software running on hardware, can literally read or write from its RAM to the adjacent nodes that are inside the cluster. That sounds pretty weird, right? What's one of these? What's that? Extreme I/O is one of those. What about a non-EMC example? VSP, by the way, is one of those. So whoever said VSP earlier. Any other examples anyone can think of? VMAX is one of those. 3PAR, any 3PAR customers in the room? So a 3PAR would be one of those, right? So why the hell would someone design it with this weird esoteric memory all shared thing? The fundamental reason is linearity of behavior. The path through the code stack is linear regardless of which way you come in, right? Sometimes that's linearity in failure modes. Sometimes it's the linearity in data services, whatever. Linearity is the driver behind this. If you were, again, anyone here who was in comp sci, raise your hand. I'm trying to bring you guys and make you part of this conversation. Otherwise, it's a little one way. Imagine writing up that piece of software. Would it be easy or hard? Would it be harder than this one over here? A lot harder. And there's a reason why these architectures, if these ones always have 1 or 2 brains, these ones have at most tens of brains. You could imagine that if you had hundreds of brains, the software development problem of all of them being able to read and write to the RAM space would get crazy hard. That's why these clusters, while they scale out, they don't scale out to infinity and beyond. Does that make sense? It's not because the engineers aren't smart or they wouldn't want it on the roadmap. It's just really, really freaking hard. It takes on a VMAX, this is 20,000 lines of code on VNX, it takes about 500,000 lines of code to commit an I/O. Relative order of magnitude complexity. Loosely coupled scale-out clusters. These ones are described by having the data kind of blammed out all over the place, but maybe it's just Ethernet or InfiniBand between the nodes, but they don't share the same memory space. What's an example of one of those? What? XIV is one of those. Teradata is kind of one of these. It's more the next category, but good guess. Isilon, I heard from someone, right? An Isilon cluster is one of these. NetApp C mode is actually a 1 with a move and manage abstraction. Remember, the main thing is about what is the I/O path throughout the I/O stack. Again, this is a good exercise. I feel like I'm getting you guys a little bored here, but there's one that I'm sure you've heard about today. vSAN is one of these, right? So again, notice software, some are coupled with hardware, but the common thing they share is their architecture. These can have hundreds of nodes, happily, right? So in other words, today we've got 32 nodes in vSAN 1, 64 nodes in vSAN 6.0. If in vSphere 7. Whatever, you know, we increase the cluster scale limits beyond 64, vSAN could architecturally scale to that level, right? Scale I/O, by the way, is one of those as well. Distributed shared nothing architectures. These are weird aliens. They have like nothing. Maybe they're loosey-goosey in sharing the data. Maybe it's kind of right, kind of wrong. I'll ask again if I get it wrong. What are examples of these? This is more like the Teradata example. But the big examples of this are object stores, S3, the things that I was describing before. HDFS is one of these, right? There's a rule of persistent stack engineering. If you are born a dog, you don't die a cat. If you are born in one of these categories, your architecture is that until the day it dies. Because it's so built into how you built the thing from the beginning, you can't switch. I just gave you the decoder ring to figure out like every storage vendor's roadmap in the world. Which one of these is right? All of them, right? And in fact, in the game that we've played in the short little time, we've talked about this diversity inside this ecosystem. People are like, I don't get it. Maybe one of these will one day rule them all, right? Doesn't work like that. It's a lie. It's a delusion. Don't be delusional. Don't listen to any vendor, me included. Be skeptical. Be a scientist. Right? Now, our view is that ultimately this diversity is why we need to build some way to abstract these. Because the ironic thing is the more of them that you have, the more complex it becomes to run and manage. We've been doing something for a while. It's freely downloadable. You can check it out. It's called the Viper Controller. I think we're going to have to make the Viper Controller even more open if we want it to actually solve the problem of this diversity of this ecosystem. There needs to be something that kind of can bring them all together and abstract them. Now, people ask, will there ever be a fifth? Answer, yes. I can see it a little bit out of the, you know, over the horizon a little bit. And this is going to be around the next generation of non-volatile memory. Okay? This is actually really cool in my opinion. You won't show up in the market at large until 2016 at earliest. 2017 is when it'll hit its full stride, but it'll change a lot. And to explain this, we're all going to play a game where for a little bit we're going to imagine we're inside a CPU, or we are a CPU. And Intel Gen 5 Core i7 awesome Haswell CPU. Okay? Inside the CPU, you have registers. You have a very small amount of them. The registers are the first place where you persist information. It's not persistent after power cycle, but it's persistent while the power is being applied. If you can't fit it in there, you put it in L1, L2, L3 cache, which is SRAM, a very esoteric, expensive form of RAM, and it's connected via on-die connections to the core itself. If you can't fit it in that, you cross over something called a DMI interface, a direct memory interface, to the pool of DRAM, right? DRAM is getting cheaper and cheaper every day. I remember when I built my first PCs, like literally, you know, getting a tiny like 120K DRAM module cost me like a year's salary, right? And now, you can basically buy like 64 gig DRAM DIMMs for like $150, right? It's crazy, right? If you can't fit it in that, you cross over something called a QPI across the non-uniform memory architecture to another CPU core. This is why CPU core count and socket count relates to the number of DIMM slots that you have inside a server. Make sense? That's a CPU complex. If you can't get it from there, you cross over a PCIe bus, a Gen 3 super fast PCIe bus, and you get in and out of the fastest next thing in the ecosystem, which is NAND. And NAND takes about 50 microseconds to get in and out of. If you have to do a write cycle, it can take longer, right? Because of how NAND is written to. And if it doesn't fit in there, you exit the server on a journey across a fabric of some form, Ethernet, fiber channel, FCOE, whatevs, and you hit an all-flash array. Maybe it's an awesome all-flash array like EMC Extreme IO or whatever, right? The point being, you get to something next. Now, each of these are larger and larger, roughly 1 or 2 orders of magnitude as you kind of progress through, right? And everyone kind of gets this at some fundamental level. Now, something that's important to understand is that when code needs to change a value, the CPU needs to wait. There's a system wait until it comes back and says, I got it. I've written it. The reason for that is kind of obvious when you think about it, because if the CPU just kept running before it got the answer back, hey, it's good, another line of code could change its value, and then you'd have a problem because the code would not know what's the correct value. Does that make sense? So persistence involves a wait. How long do you have to wait? Well, 1 nanosecond, 10 nanoseconds, 50 microseconds, 500 microseconds. Here's the next thing. Humans want simplification. Humans are also universally bad at math. Okay? So I'm going to do some math for you. First bit of math. Let's turn them all to the same unit. Do you notice something? As soon as you leave the CPU complex, things get really wonky. Now, the other thing that humans are not good at is thinking in nanosecond time scales. So we're going to play another little game. We're going to turn these into seconds. Getting in and out into the SRAM is the equivalent of me pausing for 1 second. Doesn't annoy you in the slightest. Getting in and out of DRAM is like annoying. Right? Getting in and out of a PCIe attached NAND device is the equivalent of me going, I'm out, and not coming back for a day. Right? So the point, and by the way, it gets even worse. Getting to that super fast Extreme I/O box, it sounded like I was kind of advertising. It's awesome, and it is awesome. It's the equivalent of me leaving for a week, but saying, everybody wait, right? So, by the way, if you hit magnetic media, it's the equivalent of Christopher Columbus's journey, to discover the new land, or some Cook journey out here with inmates. I don't know what this. There's some cultural, connection that I'm missing, right? The point being that leaving the CPU complex is so slow. And remember, putting all flash arrays behind traditional databases that expect LUNs is like a huge leap forward, right? So again, I'm not saying that they're bad, but for transactional things, if you can keep it in DRAM, holy smokes, that's how you build high-performance transactional systems in RAM. There's a whole wave of disruption coming here over the next 2 years. From Intel, the Skylake systems and CPUs that are arriving in 16 and 17 will have this as a centerpiece of how they're trying to tackle this problem. We acquired a company called DSSD that will melt faces like this year that is targeting this specific space. You can see also weird startup, Diablo Technologies and others trying to go at this space. Because if you can add a lot of capacity without introducing the latency, and remember, here we're talking about latencies that just seem so weird in our normal universe, but you can see for these problems, they're very important. Does that make sense? Very, very cool stuff to come. By the way, people are like, what will replace NAND? Nothing in the foreseeable future. But in this space, you will see phase change memory, carbon nanotubes, memristors, et cetera, start to show up because they're roughly 100 times faster than NAND, but still roughly 100 times slower than DRAM. So what does that probably mean? Will they replace anything? No, there's probably going to be a new level in this persistence hierarchy. Does that make sense? This is why you can't read what you read in the press all the time and listen to what they say all the time, because analysts and the press write stuff, have no idea what they're talking about. Right? And they want to make it sound exciting, like this new thing will replace this thing, because that gets eyeballs, because you're like, hey, I just bought one of those things. I want one of those things now. Right? The reality is a little more nuanced. And this is something that's interesting that's going on in storage land. Yes, all flash arrays. Yes, VVols. Yes to all those things. But the way back picture is there's a slowdown in the amount of data that's being generated on stuff that's warm, right? All that stuff kind of in the middle. And the biggest growth is actually in memory and in big, giant object and HDFS stores that are of a different type. Very alien in the enterprise. But remember, we have a time machine. The next thing that's fascinating is consumption models are changing. And you know who led this? You did. VMware did, virtualization did, where all of a sudden you couldn't be a storage dude or a networking dude or a server dude or an OS dude. You had to kind of do all those things, right? People started to realize we have to break down the silos of server, network, and storage. We started that 5 years ago with the creation of VCE and vBlocks, but that's just the beginning, not the end, right? These things are wildly successful. They're $2 billion worth of revenue last year. We think it'll be about $3 billion this year. Customers who have them love them. Anyone here a Westpac customer? If you're a Westpac customer and you like do a transaction, say thank you vBlock if your transaction goes through. If it didn't, maybe you didn't pay your bills. The point being, these things are used all over, all sorts of customers, all sorts of scales and use cases, right? They're also used in many of the Australian public clouds. However, there's a problem with vBlocks. They can't come in a small. The smallest vBlock is about a rack and costs about $500,000. 5 minutes. So we introduced this vSpecs Blue thing. Now again, there's other competitors here, and this is not intended to be a vendor commercial session. These architectures, whether hyper-converged, converged, we'll see how they evolve over time. These will be the way that you will build infrastructure in the future. The idea of standalone server, network, and storage consumption is going to go away. It adds zero value, fundamentally, or such marginal value, it's a waste of time. Now, vSpecs Blue is our offer built on top of Evo Rail. We've done all sorts of cool stuff. Each one of these has their place. But I got to tell you, 2015 is going to be face melting because here we're in February, it's going to be March soon. By the end of the year, this will expand around how do we cover more and more of these platform 2.5 use cases, the world of pets and pets evolving. And then we're going to introduce this thing called ECI, which is focused exclusively on how do we best support workloads where people want chickens. What do I mean by that? I mean, 2.5 will include things like Evo Rack appliances, part of the Evo Rail and Evo Rack program, right? It'll include different variations of hyper-converged. It'll include refreshes of converged architectures really soon, right? And then these weird things built just for the world of chickens, because some people are all about those chickens. So, putting it all together, the structure that we have inside the federation of EMC, VMware, and Pivotal is sometimes a little confusing to some. It's fundamentally about choice. Some people want EMC and VMware and Pivotal to work together. Sometimes they don't. Some customers use Pivotal and run it on AWS, and VMware hates that, right? Sometimes customers want to use Cloudera with EMC on top of VMware, and Pivotal hates that. But in the end, the customer wins. Fundamentally, that's the structure of how we operate. We each operate, innovate, disrupt, and move forward. There's places where we come together. So for example, one of them is this idea of, hey, if you want to build a hybrid cloud, you have choices. You can build it in a myriad of ways. But if you want to ask how we would answer as the federated set of companies on how to do it, if you wanted to do this, you deploy a Federation Enterprise Cloud, and here's how it's built. And what infrastructure you should build it on, converged infrastructure so you don't waste time. We've got customers around the world that have used this approach to build hybrid clouds using vCloud Air and other public clouds, and they're up and running in 2 weeks. Imagine how long it takes to deploy the vRealize suite stack on top of your existing. Has anyone gone down that project? Anyone using vSphere 5.5, VCD, vRealize operations, ITBM, all that stuff? How long has that journey been for you guys? Only starting now, right? How long do you think it will take until you're all done? Yeah. Many months? Yeah. Anyone else? It takes time, right? We've done a lot of work to pre-validate all of that stuff. The other example, and again, only this guy there in the back with the red who said, yeah, I'm all about the chickens, gets this now, but trust me, remember, time machine. If you wanted to build a data lake to do these sort of analytics things, like you were the Australian folks that are scanning my Twitter profile, we would say this is how you'd build it. This is how you'd build the infrastructure layer. This is how you'd build the data fabric layer using a ton of open source code and projects. This is how you'd build the code layer, and then you'd use cluster management like Pivotal, Cloud Foundry right beside it. Again, examples where Pivotal, VMware, and EMC come together. Closing this out, what's interesting is I'm always terrified whenever I give this discussion that people leave freaked the hell out. Because they're like, oh my God, there's so much stuff going on. And is any of this even relevant to me? So I've separated the what should you watch for and what should you do. Watch for is just like, hey, keep your eyes peeled. Do is do, right? My recommendation. Things to watch. Watch for more application diversity start to show up in your environment. And ask yourself, is this a pet or is it a chicken? Talk to the people who build your apps. Because if you're an infrastructure person, your job is to support them, right? Don't be like us and them. That's not cool, right? Have a beer. Sit down. Listen to each other, right? The next one is look for more diversity in the separation of application and persistence. You're going to start to see this tugging where you're going to be like, I can't fit this workload economically on this persistence layer. The answer is because you're trying to shove it in the wrong place. It might be a type 1, a type 2, a type 3, a type 4, different type of workload. Expect to see more diversification in how applications are abstracted, kernel mode, container, physical, as freaky as it sounds. And remember, I bleed VMware and love VMware. I think VMware is the right answer for the vast majority of cases. But keep your eyes peeled, watch for it, right? Expect big disruption in hardware, of all things, around non-volatile memory architectures over the next 3 years. Why is that relevant? It's not because of the hardware piece, it's because it will enable whole new applications that we can't even imagine right now. And look for converged infrastructure to be the dominant way on how people consume infrastructure, but it won't be one way no matter who you talk to, VC, Nutanix, SimpliVity, or anyone, or EMC with vSpecs Blue. Again, just like everything else, there will be divergence, not convergence in these architectures. There'll be winners and losers, and you guys will ultimately choose that, right? Now, what should you do? There's no time to dither. The world's moving really, really fast, right? So whatever you do, just don't sit still. That's a bad move. The second thing is to be maniacal and clear in your brain about is it a pet or a cattle workload. Understanding the differences. Build a converged infrastructure strategy, including the M&O layer, the management and orchestration layer, and automation layer for each one of them. Invest time, personal time, into the skills around management and orchestration. If you're all about Puppet, great. If you're all about Chef, fine. Ansible, great. You want to use vCenter Orchestrator? Great. But those skills to glue together and automate, trust me, as someone who is responsible for hiring and leading thousands of SEs around the world, is the most precious skill for me and the most difficult to find, which means it's valuable. If any of you are really good at that, right? Use internal pressures to innovate around the application stack, around platform as a service, around data fabrics. Just really 2 super last points. If those are what we should do in aggregate, what should we do as humans? People ask, is there a formula that I should use to navigate? Duncan Epping, by the way, wrote a really great, you guys read Duncan Epping's blog? Yellow Bricks? Duncan's an awesome dude. He wrote a great blog post this morning or wherever he is in the Netherlands around like what he's done to advance his career. People often ask, is there some sort of magic formula? Yes, clearly there is. I've written it down. There's no formula, but there's some things that I've found are commonly part of success. The first one is fearlessness. So look at the face on this dude here. This should be the face on us every day, even when we're facing horrific problems and we're freaked the hell out, right? Fearlessness is important, and my guidance to myself and to my team is human instinct to basically be scared of change, scared of risk, served us well when we were cavemen, right? Wasn't so long ago. It was 20,000 years ago, right? In evolutionary terms, it's a blink of an eye. So we still have all those, reptilian reflexes and logic deep in our brains, right? I go, when you feel fear about something, it's a cue to embrace it and run towards it, as opposed to running away from it. So you feel fear, you feel a little tightness, run towards it, whatever that thing is. I've made one Australian addendum to that. The last time I was here, I was talking to the EMCSEs, and they're like, Chad, you know that there are animals here in our country that if you do that, they will kill you. So I said, fine, arm yourself with a pointy stick. Okay? So charge towards your fear, use it as a cue of where you need to go versus where you need to run away from. Right? The second thing is passion. Whatever you are passionate about. Again, an interesting thing. Did you guys, anyone who follows Scott Lowe? Scott Lowe was like #1 blog dude for a long time. I'm like number 8. Like I dream of being in the realm of Duncan and Scott, right? But for who here reads Scott Lowe's blog? Did you notice a weird, like all of a sudden change in his like whole blog tone? He basically, was working on my team as a V specialist, all about VMware. He had built his career around VMware, and then all of a sudden he's like, you know what? I'm passionate about networking and open source. And so we said, fine, be fearless. Stop what you're awesome at. Think about how he could have just kept doing what he was doing. And we moved him, and he became part of the NSBU, the NSX team within VMware. And his job shifted to focus on open source. And his career has only expanded from then. What he did is he followed his passion. So whatever your passion is, my advice, follow it. So with that, thank you for your time. I really appreciate listening. Please give me feedback. Thank you for being VMware and EMC users as well as our competitors. And thank you for joining the VMUG. They're awesome.